Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel, please don't forget to subscribe and press the notification bell so that you will be updated on my future lecture videos about the subjects in civil engineering. So this video discusses 3 examples on frames and machines. So this is the second part because I already uploaded the first part and there were also 3 problems. So I hope that you can follow the solution by watching it and closely listening to the discussion. And most importantly, I hope that this lecture series that I uploaded in YouTube will help you in your studies and in your future career. So good luck. So here is the first example. Determine the component reactions at pins A and C caused by the given loads. So here is it. This is the figure. And take note that E is a roller. So therefore, we can consider first the free body diagram of member DE. So let's consider the free body diagram of member DE, and next is BC. So because E is a ruler, then we have only one reaction component at E, which is upward, as well as at D. Then DH is obviously 0 if we sum up forces horizontal. So summation moment about we have here also the free body diagram of member BC. So we transmit the vertical reaction at D, so it is now downward. And we sum up moment about D to solve for R sub E, considering this free body diagram first. So R sub E times 2.4 minus 270 times 1.2 equals 0. So R sub E is equal to D sub V also if we sum up forces vertical equals 135 newtons upward. Then we transmit that 135 newtons upward at D. Then let's assume these component reactions at B and C. So we have C sub V, C sub H leftward, BH rightward. Then summation moment about C or B equals 0. So C sub V clockwise positive times 2.7 minus 135 times 1.2 equals 0. Solving for C sub V is equal to 60 newtons. So by computing for B sub V, summation forces Y, so B sub V plus 60 equals 135. So B sub V is 75 newtons upward also. Now we have found B sub V, then we draw the free body diagram of the remaining member AB. So by the way, BH is equal to CH if we sum up forces horizontal in this member BC. So considering the free body diagram of member AB, we transmit the reactions. So B sub V is 75 downward. So we have EH, AB upward, and 75 downward for B sub V, and to the left B sub H. And the force 450 at the center of that member. And we have distances 1.8, 1.8, and the vertical distance is also 1.8 from this figure here. So we sum up moment about A equals 0, considering clockwise positive. So we have BH times 1.8 plus 450 times 1.8 plus 75 times 3.6 equals 0. Solving for BH is equal to negative 600 newtons. So it means that it is rightward. Here it is leftward. and CH should be rightward. Or CH is the negative of because BH equals CH is negative 600, so that means CH should be rightward. So CH should be equal to 600 Newton rightwards from the relationship we established already above. Then that's the answer because we are required for the component reactions at pins A and C. So we already solved the pin reactions at A and C, at C rather. Then at A, you may have summation forces horizontal and summation forces vertical. So summation forces horizontal equals 0. So EH equals BH, and since BH is negative 600, then AH also is negative 600 rightward in this member, but the final answer is leftward. So AH equals 600 newtons leftward, and summation forces vertical equals 0. A sub V minus 450 minus 75 equals 0. Then A sub V is equal to 525 newtons upward. So that completes the analysis and the requirements in this problem. So let's have example 5. Determine the components of the force exerted by the axle of the pulley upon the member AC and upon member CE. The weight is equal to 800 newtons. So this is the figure. So we have a roller support at A, then at E, a pin. But if we consider the whole system, so that's R sub A, E, H, and E sub V. So obviously, if we sum up forces horizontal, EH is 0. So let's sum up moment about E equals 0. And before that, let's solve for the radius of the pulley. And this is also R because the cord draped around this pulley here is parallel to this member CE. So this is also R, and the angle here is theta. So let's call also that angle theta. So where the slope of this member CE is 2.7 up vertical, then 3.6 horizontal, which can be reduced to 3 vertical, 4 horizontal, so 5 hypotenuse, like that. So therefore, R is equal to 1.2, the hypotenuse, this length, times sine of theta. So 1.2 times 3/5 sine theta is 3/5, opposite over hypotenuse. So R is 0.72 meter. So, but in this problem, that's not important. What is important is the slope theta. So summation moment about E equals 0, counterclockwise positive. So R sub A times 3.6 minus W, and the distance of W is quantity 3.6 plus the radius. So the radius is 0.72. So RA is equal to 1.2 W. Then summation forces vertical equals 0. This is 1.2. So the E sub V should be downward. So E sub V plus W equals 1.2 W. Therefore, EW or E sub V is equal to 0.2 W downward. Then take note that E sub H is 0. So considering the whole system and summation forces X, EH is 0. So this is the free body diagram of the portion ABC. Then if remember that there are two members here, and we are computing for the components of the force exerted by the axle of the pulley. This is the pulley upon member AC and member CE. So that's a free body diagram. If you sum up moment about C equals 0, so BH equals 0. Likewise, if you sum up moment about B equals 0, then CH is equal to 0. Then we draw the free body diagram of member BB. So EH is 0 as mentioned earlier. So CH times 1.8, summation moment about B equals 0, CH times 1.8 plus nothing equals 0, so CH equals 0, and therefore BH is also equal to 0. If you sum up forces horizontal, then this is the free body diagram of the portion BD. So we have here the tension in this cord is equal to the W. The pulley is frictionless, of course, it's not mentioned. Then if we sum up moment about D equals 0, then we have counterclockwise positive vis-a-vis times 2.4, then minus W sine theta, the vertical component, the horizontal passes through the times 1.2 equals 0. So vis-a-vis times 2.4 minus W sine theta times 1.2 equals 0, where sine theta is 3/5 or 0.6. So vis-a-vis times 2.4 minus W times 0.6 times 1.2 equals 0. Solving for vis-a-vis is 0.3 W, and it is upward for in this member, downward on the other member. So from there, if we sum up forces vertical, we know that CH is 0, summation forces vertical, we can now solve for C sub V. So 1.2 W plus C sub V equals minus 0.3 W equals 0. 1.2 W, summation forces vertical, this is the equation, plus C sub V minus B sub V or minus 0.3 W equals 0. So C sub V is negative 0.9 W. That means that C sub V is 0.9 W and it is downward. So on member AC, the force exerted by the axle of the pulley to member or upon member AC is equal to 960 newtons downward, or 1.2 times AV is 1.2 times W, 800, 960 upward. So that's the reaction at A, pin reaction at A. Then at C, it is CH0 and C sub V is 0.9 times 800, 720 newtons downward. So that's the answer for the force exerted by the axle of the pulley upon member AC. Now we proceed to the force exerted by the axle of the pulley upon member CE. So let's draw the let's solve first the DH, summation forces horizontal equals 0. So W cosine theta minus DH or equals DH. So DH is equal to 0.8 W because cosine of theta is 4 over 5 or 0.8. So having found that, we can now draw the free body diagram of member CE. And before going to that, let's sum up moment about B equals 0 to solve for D sub V. So D sub V times 2.4, that's counterclockwise positive. D sub V times 2.4, then minus W sine theta or W times 0.6. The moment arm is 3.6. 1.2 plus 2.4, 3.6 equals 0. So D sub V is positive 0.9 W. So this is correct. So we transmit this W on member CE, free body diagram. So take note that at E sub H is 0, only E sub V is 0.2 W. Since this is an external support, the reaction is still 0.2 W. It will not be changed. We only apply action-reaction principle for internal pins. But for external pins or reactions, the original direction of component reactions remains the same. So we have now transmitted 0.9 W upward for D sub V. Then this is 0.8 W from this member. So when transmitted to the other member, it is now 0.8 W to the right. So these are the component reactions at C and at C due to the force exerted by the axle of the pulley upon this member CE. So obviously, if you sum up forces horizontal, CH would be 0.8 W, And if we sum up forces vertical, 0.9 W minus 0.2 W minus C sub V equals 0. So C sub V is 0.7 W downward. And CH is 0.8 W leftward. So CH is 0.8 W leftward from this free body diagram. Summation forces Y, 0.9 W, then minus 0.2 W minus C sub V equals 0. So C sub V is 0.7 W, and since it is positive, our assumed direction that C sub V is downward is really downward. So that's it. So on member CE, the force exerted by the axle is the CH is 0.8 of W, 800, 640 newtons leftward, and C sub V is 0.7 of W, so 560 newtons downward. So this is the complete solution to this problem here. So you may check by summing up moment about C. So 0.8 W times 1.8 clockwise plus 0.2 W times 3.6, then minus 0.9 W times 2.4. It should be 0 to confirm our answers. So finally, let's have a machine. The scoop of a bulldozer is loaded with 40 kilonewtons of sand, gravel, and soil mixtures with center of gravity at G. Note, there are two leakages and only one is shown in the figure. For the configuration shown, find the force F acting in the hydraulic cylinder AB and the force on the pins at C and D. So the force on this cylinder AB and the pin or force pin reaction force at C and D. So first, if we consider the free body diagram of this portion here and this one, it's like we cut this member here and we sum up moment about D, then we can compute the force of this link EK. So we apply the loads. Since there are two linkages, only one is shown, then we divide the total load, which is 40 kilonewtons, by 2. So we have to apply 20 kilonewtons and transmit it to this link. So we consider the force of member EK as in that direction, compression. So if you look at the figure, it should be down to the left so that it opposes the moment of the load about point P. So instead of slope, we compute the angle that EK makes with the horizontal. Tangent of this angle is 0.75 divided by 1.45 plus 1.05 is 2.5. So arctan of 0.75 over 2.5, that gives us an angle of 16.699 degrees. And there are two components here, horizontal and vertical. The moment of the horizontal is clockwise, the moment of the vertical is counterclockwise. So let's consider clockwise moment as positive. So summation moment about D equals 0. Let's assume these are the component reactions. If we consider this part only, so FEK times cosine of 16.699 clockwise positive times moment arm is 0.75 plus 0.375 is 1.125. Then minus FEK sine of 16.699 times 1.05. Then minus 20 times 0.75 plus 1.05 is 1.8. So minus 20 times 1.8 equals 0. So solving for FEK is equal to 46.401 kilonewtons. And since it is positive, our assumed direction for FEK is correct. Then we can now compute DH and DV for this member here, DH. So summation forces X equals 0. So DH is FEK cosine 16.699. So 46.401 cosine of 16.699 is equal to DH. So DH is equal to 44.444 kilonewtons. Then summation forces vertical vis-a-vis, then vis-a-vis minus 46.401 sine 16.699 minus 20 equals 0. So vis-a-vis is 46.401 sine of 16.699, then plus 20. So vis-a-vis is equal to 46.401 sine of 16.699 plus 20 equals 33.333 kilonewtons. So having found d sub h and d sub v, we can now compute the force at D. It is equal to the square root of 44.444 square plus 33.333 square. So R sub D is equal to 55.555 kilonewtons. So that's the force at pin D. Now we isolate member this body here. So of course we apply action-reaction principle. So DH and DV will now be transmitted opposite to these directions. So this is the free body diagram. D sub V now is downward and D sub H is leftward. These are the values. Then we have here the force in member AB, then the component reaction at CH. These are just assumed. So based on the values here, so this may be the direction of the component reactions at C. So let's solve for the angle here instead of slope. So this tangent of this angle is 0.375 plus 0.375 is 0.75 plus 0.75. So that would be 1.5 plus 0.3, so 1.8. So tangent of this angle is equal to 1.8 divided by 0.9 meter. So therefore, we can now solve for that angle. It is equal to 63.45 degrees. So again, the 63.45 degrees is arctan of 1.8 divided by 0.9, or arctan of 2. So there are two components. One is horizontal, the other is vertical. So if you want to solve for FAB, we sum up moment about C, and both horizontal and vertical components produce clockwise moment about C. So we treat clockwise positive. So that's also 63.45. So for the horizontal component, FAB cosine of 63.45 degrees times 0.375, then plus FAB, the vertical component, sine of 63.45 degrees times moment arm 0.9, that's 0.9 there. Then 0.9 plus 0.15 is 1.05, plus 1.45 is 2.5. So that's why the distance is shown in the figure. So plus FAB sine of 63.45 times 0.9, then plus 44.444 times 0.75, then minus 33.333 times 2.5 equals 0. So solving for FAB, the only unknown in this equation, FAB is 51.403 kilonewtons. Then finally, we sum up forces horizontal and vertical to solve for these component reactions. So CH is CH minus FAB, 51.403 sine of cosine of 63.45 minus 44.444 equals 0. So CH therefore is 44.444 plus 51.403 cosine of 63.45. So CH is equal to 67.42 kilonewtons. So the direction is correct. Then C sub V, summation forces Y, is FAB 51.403 sine of 63.45 degrees minus 33.333 minus C sub V equals 0. So from there, we can solve for C sub V equal to 12.640 kilonewtons. Then finally, the force at C is square root of 67.42 square plus 12.643 square. So R sub C is equal to 68.607 kilonewtons. So these are the answers, and I hope that you can follow the solution. And I hope that the explanations are enough for you to follow these solutions. And I hope that you enjoy watching my videos, and I hope that my videos are very helpful in your studies.